All right, well, welcome everybody. Welcome to today's webinar. My name is Brent Mosher. I'll be hosting the webinar today with my counterpart, Vasanthan Kumar. Today we are talking about identifying and mitigating software delivery risks to achieve continuous delivery with Spinnaker. Vasanthan leads the product management for our AI and analytics at OpsMx. He has over 20 years of experience in building AI and ML systems for enterprise IT companies and for enterprise solutions. His deep interest lies in technology development and product engineering. He's built multiple machine language-based intelligent risk and assessment software with DevOps space and enabled teams to deliver software without human intervention. Before we get going, just a couple little housekeeping items. We are recording this webinar, as you can all see. We will be sending out the deck at the end of the presentation along with links to the recording. If you have any questions or chats, go ahead and put them in the chat box or the question box now. We'll get to them actually at the end of the webinar as well. So a little bit about OpsMx. You mind switching the screen, Vasanthan?
Sure.
So a little bit about OpsMx for everybody. One of the biggest things we try to do is we try to, deliver software without as much human intervention or any human intervention at all. Our vision is to enable enterprises to deliver software as fast as possible and to do it in a very effective manner. We believe that helping organizations modernize business applications, they need to focus on adopting to cloud-native architectures, modernize continuous delivery, and automate infrastructures. Today's webinar, Vasanthan will actually introduce our delivery intelligence module, or Autopilot, and this module is part of our overall intelligent software delivery platform. And we have two modules that are in there: continuous delivery module, which highlights real-time insights, automated workflows, and automated multi-cloud deployments, and delivery intelligence module, like I said, he'll actually go over today, which highlights some of our approvals in collaborations, automated policies and governance, security, intelligence and automation, and continuous verifications. Our goal is to improve productivity with DevOps teams, to automate workflows, leverage MI and ML into central policy engineering to increase velocity, quality, and security of your software deliveries. So with that, I actually want to launch our first poll. We like to have a couple of polls in our webinars. So there's about 4 questions here I'd love for you guys to go through. And feel free to take your time. We'll leave this poll up for just a few more minutes and allow people to interact and tell us their views and feelings. Don't be shy, people. You can fill it out. We're not going to steal your information and sell it, I swear. We're getting a few more polls coming in now, so thank you everybody for filling this out. And once this poll is over, I'm going to pass it over to Vasanthan, and he can actually just lead the webinar that you guys are all here to be involved in. I see a lot of people are Spinnaker users, which is exciting. So I think I'm going to let the poll run for just a few more seconds, and then we can get going. All right. One more. I'm doing the countdown here. We are at 5 seconds. All right. Oh, look at that. Oh, somebody just clicked another one. We reset. Well, thank you everybody for doing the poll. We're going to end that now, and I'm going to let Vasanthan take the presentation from here. So with that, Vasanthan, off to you.
Thank you, Brent. Just give me a minute.
We lost your screen there for a second, Vasanthan.
Yeah. Can I? Just a second. I have some trouble in starting. Just give me a minute.
Would you like me to share, or are you everything working fine for you?
Fine. Yeah.
Okay.
Right. So I hope all of you can see my screen. Brent, can you see the screen?
Yeah, we see the title slide right now.
Right. Okay. All right. Let me start. Thank you, Brent. Sorry for the
No worries.
problems. Yeah. Okay.
Technology makes everything fun. You just never know when it's going to work or not work.
Right. Yeah. So what I will do is I will take the first few minutes to talk a little bit about what are some of the challenges in the continuous delivery, how OpsMx as the platform addresses these challenges. And I will just take one specific use case of continuous verification and how we do this with ISD, both with Spinnaker as well as with Argo as the CD platform. Okay, and I'll continue with the demo of the same. Right. Yeah. So most modern enterprises have automated their software delivery process using continuous delivery.
Vasanthan, I don't want to interrupt you, but we're still just seeing the title slide. So
Okay.
I believe you're trying to move ahead.
Okay. All right. Yeah.
There we go. Beautiful.
Okay. All right. Right. Yeah. So most modern enterprises have automated their software delivery processes using some continuous delivery platform. It could be Spinnaker, Argo, etc. Yeah. So platform teams are able to deliver the code faster, deliver their changes more frequently, and they can also scale as per the business needs. But still the question remains, is the speed is sustainable, right? The truth is that most enterprises will increase the rate of failed application deployments also as they increase the rate of deployments. As the code moves from build to QA, from QA to staging and staging to production environments, we still have many checks which cannot be completely automated. For example, you need to run your security scans using SaaS or DaaS tools. You need to run large number of functional tests in QA, compliance to organization policies, and also in some cases, there are manual judgments. Other than functional tests, you need to check performance, resource consumption of the new software update, whether it's within the limits. All these steps still take a lot of amount of time. This is where OpsMx can help you. So as Brent mentioned initially, so OpsMx Intelligent Software Delivery Platform has two parts mainly. So one is the continuous delivery module, which is basically our OpsMx Enterprise for Spinnaker, right? So it has all the features what you typically look for in a modern CD platform, which includes automated workflows, multi-cloud deployments, role-based access control, CI integrations, role-based access control, CLIs, multiple deployment strategies, notifications, etc. Right? So, and then we have the module 2, so which is the delivery intelligence module, which we call as the Autopilot. So in addition, we have a host of tool integrations which are shared by both the CD and the intelligence module. So let's take a deeper look at our intelligence module, the Autopilot, and what it has to offer. So here comes OpsMx Autopilot, an intelligent layer for software delivery. The core functionalities includes, firstly, the verification to help DevOps and SREs to automatically identify and mitigate risks at all stages of a CD process. It does this by leveraging the machine learning techniques on application logs and metrics to find regression issues. Later in this session, I will show you how you can use this function to help your organization to reduce risks without manual intervention. Once you're able to reduce the manual intervention to mitigate the risks, you will unlock the ability to increase the release velocity. You can save a significant amount of time and dollars by eliminating human intervention. Next is the continuous governance and security. Autopilot helps DevOps teams to define compliance policies and enforce them in the delivery pipeline. So example of a policy could be, say, new deployments are allowed only within a certain time interval, say outside the working hours. It's an example of a pipeline-specific policy. Many of these policies also involves RBAC or the role-based access control in some way. Say a policy could be like, which stipulates that RBAC needs to be enabled for each pipeline and there should be at least one user group which has the right access to the pipeline. So this is one policy which is used by one of our customers. Also, a policy could be like which allows that new pipelines can be created or edited by a certain user group. An orchestration tool like Spinnaker may already be providing a minimal RBAC to do this. They may also have a templatized approach which defines how each pipeline should look like. But in many cases, you may need a fine-grained control. You're okay if a user makes changes to some stages, but there are certain critical stages which you want to restrict to only a few users. Other requirement could be that you don't want the user to change the sequence of stages in a pipeline, but they're free to make changes to any of the stages. Having a policy engine makes it easy to handle such scenarios. So next comes the informed approval. Autopilot is able to collect information from DevOps toolchain to help release managers for faster decision making. For example, you may want to run static code analysis using SonarQube, or you want to run some security scans using Prisma, Cloud, or JFrog X-Ray, or AppScan. Based on the results of the scanning, you want to proceed with the deployment. Autopilot helps to automate these steps. We have built-in integrations with many of the SaaS DAS tools, monitoring tools, source and image repositories, which you're already using, which makes it convenient to pull the information from these tools for automated decision making. Lastly, the observability, traceability, and insights. Autopilot provides delivery, usage, and approval dashboards for continuous delivery. Other than the application level dashboards, Autopilot offers aggregated dashboards, which gives a peek of how the overall performance of the continuous delivery is. We have also built audit trail. Because Spinnaker or any other orchestration tool are not only deploying your applications, but also spinning up, managing, and deploying cloud infrastructure, they have a good sense of what is already in production. But these orchestration tools do not provide a full history of what was changed, by who, and when. Autopilot provides a strong audit trail capability that makes full deployment history available to users. Okay, so let me start with, so one of the continuous verification use cases, which is the Canary Analysis using Autopilot. Let us take a look how we can do Canary Analysis for deployment using Autopilot. And I believe many of you or most of you are already familiar with this Canary release. To summarize, a Canary release is a technique to reduce the risk from deploying a new version of software into production. A new version of software, referred to as Canary, is deployed to a small subset of users alongside the stable running version. Traffic is split between the two versions such that a portion of the incoming requests is diverted to the Canary. This approach can quickly uncover any problems with the new version without impacting the majority of the users. The quality of the Canary version is assessed by comparing the key metrics that describe the behavior of the old and the new versions. If there is a significant degradation in these metrics, Canary is aborted and all the traffic is routed to the stable version in the effort to minimize any impact on unexpected behavior. While it is possible to use the existing production cluster rather than creating a baseline cluster like what I am showing here, probably the production cluster is already running for quite some time, and maybe its state is not kind of comparable with the Canary release, right? So most of the time, so when we're doing the Canary analysis, it's no, people prefer creating a new baseline along with the Canary. OpsMx Spinnaker is the one which, or the enterprise for Spinnaker, our continuous delivery platform, handles the life cycle of the baseline and the Canary clusters. Right. So this is an example of a pipeline, so which is used for Canary analysis, right? So basically there is a Git trigger, so which basically triggers this pipeline. And then we run a sonar scan and a sonar report, but this is optional. And this is followed by a Canary build, right? And at the same time, and then there is a Canary deploy, right? So together at the same time, so we also have a baseline deploy, exactly starting at the same time, right? And then there is a small wait period here, a wait stage. So which basically waits for stabilizing the newly created clusters or pods, as the case may be. And then the loading starts. After the wait, the loading starts, right? So this is a kind of a demo pipeline. So since I don't have actual users, so we're just running a load here. And using this load, we do the verify analysis. So this verify analysis stage is our verification stage built by OpsMx, right? So in this verification stage, basically it consists of two parts. So the part one is basically pulling the data from the different logs and metric sources. So in this example, what I'm going to show you, basically I have used Elasticsearch as the log source and Prometheus as the metric source, right? And then the second part is the analysis part or the judgment part, right? So it looks at the data, the different matrices that are configured, right? So here you can see a sample report, what we show here, right? So it consists of various performance metrics, the latency, the throughput, the CPU, the error rate, right? So all these multiple latency metrics, 99th, 90th, right? So also there can be custom metrics, right? So using Autopilot, one will be able to configure each of these metrics independently. So it can have different thresholds, and you can define the criticality of each metric separately. And it can have different, like I said, so you can define whether you want to fail it only when the Canary goes higher, or whether it goes both higher or lower, and whether the deviation should be 10% or it should be 30%. So all these things you'll be able to define in our templates, right? So based on, so it's not just the metrics, I'm showing here only the metrics. As I already mentioned, we analyze both the logs as well as the metrics. So the logs are typically the application logs, right? So we do some machine learning techniques to clusterize the logs coming from the application logs. And then we run our analysis to identify if there are any issues. So this is pretty useful in the sense you will also be able to correlate with your metrics and see if there is some issue in the latency. Is there any dependency on something that's happening in database calls or some such things? You'll be able to uncover with our combined log and metric analysis. Yeah. So based on the result of the analysis, so you can then here I have also introduced a policy. So we have a feature called the policy. The blacked out time is a policy. Basically, it checks whether is it allowed to deploy the software in this time, right? And then finally it goes to production, right? So I'll continue with the demo after a few minutes. Okay, so the first one what I showed you is with Spinnaker as the CD platform, and so it's little bit it's on the same lines, but with some small changes how we do it in Argo Rollouts, right? So Argo Rollouts here we are not exactly doing a canary deployment. It's basically a progressive rollouts. That means that you'll be able to set the different steps for your rollout, say 20%, 40%, 60%, or whatever you want. And in each step, you do an analysis to decide whether you want to progress to the next stage, right? So here, stable version I have shown as pod 1, but basically it's not one pod. It would be, yeah, probably 10 or 100 pods, whatever, depending on the traffic. And the baseline and the Canary, similar to what we did in the Spinnaker. Here it's, so some slightly different term is used. Here it's called as an experiment, right? So where we simultaneously create both the baseline version and the Canary version, and we push their, based on the tags, we push their logs and metrics to the respective monitoring providers, and then invoke a job, which is defined through an analysis template. And using that job, we in turn trigger Autopilot to do the analysis and get back the results. And we use those results to decide whether to promote to the next step in the progressive rollouts, or you want to roll back to the previous version. Right? So this again, I will continue with the demo. Yeah, I'll shortly start with my demo. So these are some of the things what you will see. So how you can leverage Autopilot to perform reliable risk assessment during deployments. So how the machine learning based analysis for metrics and logs, integration with different logs and metric data sources in the DevOps toolchain, some of the policy violations and audit history, and pipeline execution dashboard or the audit trail. These are some of the things that you will see. Okay. So I will switch to the demo now. So this is the demo pipeline that we have in Spinnaker, right? So I will. Yeah. Before continuing, and just to save time, I will just trigger the pipeline first. So it started now. So I'll just change my screen share. So, so the pipeline execution has started. So this is the cluster, the namespace where I'm deploying. So already 3 pods are running. So it's a service where I have 3 pods running. It's called the issue gen. So right now, so the sonar scan has happened, and currently the Canary build is happening. So while the build is happening, so let me just go back and show you the analysis screen so that right. Yeah. So this is our analysis screen. So this particular analysis has a score of 62. So it has done both the log analysis and the metric analysis. So I'm just showing this from the past data because the current one is still running. Still, it could take time. So right now the Canary deploy has happened and the baseline deploys. So maybe we can just see. So container creating, right? So this so here what you see here is a summary of our analysis report, right? So we have the logs. It did not find any issues in the logs. So the score is 100. The log score is 100. And while the metrics, so there are 5 metrics which are configured. So the latency 90th, the memory, the CPU throughput, and the latency, overall latency, and out of which 2 have failed. So there's some deviation, and the other 3 have passed, right? So the overall, since I have set the weightage of all the metrics nearly the same, so the overall, so the metric weight is around 60, and this is I have set the threshold as 50, so it has still passed this one. So you'll be able to go to each of these and you'll be able to see the results. So this is the memory, this is the CPU. So you can see that it's still increasing. Probably we need to give more time. No, here just for the demo purposes, I have made it very short. So I have waited for only 1 minute. Probably more time is needed for doing this. So the Canary deploy has happened, baseline deploy has happened, and there is a wait time of about 1 minute for the new pods to stabilize. So the load has started. So, and the data collection has started for verification, right? So now these are in the running state. So the baseline, so this the issue gen V1 is the baseline pod, and issue gen V2 is the Canary pod. And basically we are collecting the logs and metrics from these two, and then doing the analysis on top of this. Just for the demo, I have kept it very, very short. So typically this is done for a few hours of time, but here I have just set it for 3 minutes so that I can show the complete pipeline execution here, right? So, but still it will take another 2 minutes or so. So let me come back. So, right, so if there are any log issues, which I will later show in another example, so that will also come here, right? So it will basically collect all the logs and inform different clusters. And if there are some issues, so those issues also will appear as unexpected. And then there will be a scoring depending on the number of issues that you find, right? And you will also we have a correlation screen wherein you'll be able to correlate between the logs, the timing of the logs or the issues in the logs and the metric values. You'll be able to do the correlation. Yeah. Okay, so let's, yeah, still it could take about an hour. So anyway, I want to show the audit trail feature that we have. So here, whatever we are doing, everything, the pipeline execution, you'll be able to see here in this audit trail page, right? Say for example, this is one of the previous executions, right? So you'll be able to see all the execution data, right? So the complete execution data you'll be able to get here. You'll be able to see the duration of the different stages, what stage took how much time. So if there is some issue, you'll be able to look at this. So you will get a host set of data. Say for example, you'll be able to see who triggered it, who is the cloud provider, what is the build number, right? So what is the image? So all these information you'll be able to get. So it's kind of a so if there is some issue in a particular image ID, you'll be able to do a quick search of the ID, and then you'll be able to see when it was deployed, and you'll be able to see the details, who approved it, who triggered it. All these details you'll be able to find with this audit trail. Okay. So in addition to this, we also have these dashboards, right? So basically, which gives a summary of all the deployments that are taking place, how many deployments in a day, how many have passed, how many have failed, what are the most active pipelines, So what are the most successful pipelines, and what time it took for the manual judgment. So all these information you'll be able to get. So a little bit more detailed information also regarding the usage of the various intelligent gates that we have, the various pipeline executions. You'll be able to find all that in this usage insights page. So, and also, of course, the summary of all the verification that has happened in the past, summary of all the approvals. So we have different dashboards for these purposes, right? So we will come back here. Right. So the analysis is complete now. So this is the analysis stage, and this is the result. So looks like all metrics seem to have passed, and I can just click on it. So, and navigate to the report. Right. So again, logs, since we didn't introduce any errors at this point of time, so there are no log errors. And metrics, yeah. So we have all the metrics. So this is the throughput, basically the number of API calls handled by the baseline and the Canary. So this is the CPU consumption. The blue one is for the baseline, and the red one is for the Canary. And this is the latency 95th, means the 95% of the API calls are now the latency, the response time is below this. That's the limit. So this gives the graph, and you will also be able to see the actual values here, the statistical values. So what we do here is more of a, it's not a kind of a threshold comparison. It's a statistical comparison. So you'll be able to see the different values of mean, median, Q1 and Q3, etc. here. So, and it also gives a result saying that it's a similar distribution what it's seeing here, right? So, right. So this is how we do Canary analysis for Canary deployments using Spinnaker, right? So. So we have a template definition wherein you can define the kind of query that you want to run, and also what kind of metrics you want to set, what limits that you want to set, now what weights you want to set for each of them. So all this is possible with the template in Autopilot. Okay. Okay. So with this, I'll move on to how we do it in Argo. So I'll okay. Okay. So right. So let me start with how we do it in Argo. So Argo has custom resource, what is called as the custom resource definitions, called the rollout. So in the rollout, we define how we want to do the progressive deployments, right? So here you define which is the image which you want to deploy, and basically here, what are the steps? You define the steps. There is the weightage, and what is the pause? How much you want to wait for stabilization, and what experiment do you want to do? What exactly do you want to do in this step to really ascertain that if the deployment is okay and you can continue to the next step. So you will define it here. So the definition includes a template. I will show you the template called the OS analysis job, right? And basically here, the template will get the hash of the baseline and the Canary pods that gets created during the experiment. And you also define the lifetime, how long do you want to run. I have just kept it very short, say it's only 0.05, which is 3 minutes. So, and then the next step, right? So each step you can define a different experiment actually. So it need not be the same. Right now I'm using the same experiment, but so maybe for the first step you can do a very detailed analysis running for some hours, and later for the next steps you may only want to do it for a very short time. So you have the flexibility of defining or changing it in every step. Yeah, so first is 20, and then you have 60. No, that means 60% of the traffic is routed to the new software, and the next step is the 80, right? So okay, so this is how. So this is the rollout definition. So, and then we have the analysis template, right? So this is where we invoke Autopilot, and with the required parameters, right? So we give here the information, what is the time period now you want to invoke, what particular application you want to call. So what is the initial delay after starting the baseline, after the start of the experiment, after creating the baseline and the canary part, how much you want to wait, right? And what is the URL that you want to invoke, right? So you define all this in this template. Okay, so now I will start an experiment. So for that, I'll go back to rollout. So here it's 3.0.2. So this is the application that I have deployed, and here it shows 3.0.2. So let me go and change this to say 3.0.3. Just commit changes. Come to the Argo CD, right? So I have defined an application here in Argo CD. I have given the link to the Git repository, so that any change that happens in the repository, it will result in trigger of the syncing process here. Right now, I have not made it automated trigger, but it's no, it already sensed that there is an out of sync, and it shows it in yellow. So then I will start with the sync. Okay, the syncing has started. So now you can see here. So now we will go back to the terminal. So this is the namespace. Now we are in the namespace where we are deploying. So you can see some changes. So here it had 5 pods at the beginning. Right? So these were the 5 pods which were running. So now the first step is actually 20%. So one of the existing pods which are in production is going down, and one new one is getting created. Okay. Right. So you can see here. So the one which was running earlier, now there are only 4 of them, and this is the new part with the new software release which is created. And then along with that, the experiment has also started, right? So this is separate from this, right? So the 20% weightage, I know here I'm not using any ingress, no, so there is no traffic shaping here. So it's only by distribution of the load to the different pods. Okay, so so that's why out of 5 pods for 20%, a new pod got created, 1 got killed, and then the experiment, one baseline, one canary pod got started. Okay. So still there is a 90-second stabilization time. So it's still the analysis has not really stopped, but still you will see some things interesting happening here. Okay, so the experiment has started already. Okay, but there is an initial delay of 90 seconds, right? So it's just running for a minute. So this is the rollout has started, and the experiment has started, and the experiment has already created the baseline and the canary. So it's only one pod, but it's basically a replica set. So what you are seeing are the new replica sets that got created. Okay, so right now it's a replica set with only one pod, but you can choose to have, say, 3 pods. Okay. And then simultaneously, after 90 seconds, a job gets triggered. Now this job in turn will start the autopilot analysis, and the analysis will run for the duration, and it will give back the results, and which will be used for promoting it to the next stage. Right. So that's the sequence, how it happens. So this will take a little time. Yeah, so it's total duration. It will take, okay, we are, no, it's about 2 minutes. So totally it will take about another 3 minutes for the whole process to complete. But in the meanwhile, I'll again go back to OES and I'll just show you a previous analysis that has happened, right? So this is this is one previous analysis for in the progressive rollouts in one of the steps what has happened, and this is the aggregate result of the logs. So it gives a score of 98 for the logs. So it's like a credit score. The score is a number between 0 and 100. So it found some 4 warnings, in the in the logs, so mostly related to some different, some Postgres and some other warnings, right? So and then the metric, the metric analysis, of course, will look similar to what you saw earlier, right? So we have the same set of metrics, but this is basically done with Argo as the CD platform, using Argo CD as well as the Argo rollouts. Right, so let's go back and see what's happening. Right, so we are close to 4 minutes, so just 1 more minute and we should be done. But that would only be the first step. I hope you understand here. So yeah, it will take much longer to complete the cycle because we are doing it for every step, in the progressive rollout, right? If this is successful, then the next increment will be for 60%. So that means that it will increase the load on the new software to 60%, and then again we start another experiment. Right, so like that, since I have 3 steps here, so there will be 3 experiments that will happen. But in any step, if it fails, basically the experiment fails, so then the result will be a failure and the rollback will happen. Right, so that's how it works with progressive rollouts. So essentially, yeah, so it's completed. The first experiment is completed, and it's a success. And now, yeah, before further, we can see what's happening here. So 2 more pods are getting terminated, right? So 2 more pods which are in production out of 5. Now it is 60% load is for the new software. So basically, it will be 3 pods for the new software update and 2 pods for the one which is already in the production, right? So now we will go back and see the results. So this is the previous, so right. So it is 150 is the analysis core. We can navigate to it directly. Yeah, so there are no log issues in the log. So it's 100 score for the logs, but for the metrics, 1 metric has failed. Let's take a look. It's the latency 95th. Yeah, there seems to be a little bit, the deviation seems to be on the higher side. I think I had given approximately 30% as the threshold. So, but here it looks like it's more than 30%. So basically this has failed. But basically, this can happen for different reasons. So typically a bunch of matrices are used and an average value gets calculated. And if 8 of the 9 metrics have passed, so still the result is a pass. Okay. So yeah, so now the next experiment would have started already, so which you already saw, I think. So this will continue, not depending on the number of steps that you would have set in the rollout CRD, right? So this way, using the same Autopilot verification engine, we are able to use it for Canary deployments, right, and as well as for progressive rollouts in Argo. Yeah, Brent, yeah, with this, I'll kind of conclude my presentation. Yeah, you can take over.
Well, awesome, Vasantha. Thank you again for walking through all of this for everybody. You know, it's nice to see how the tool actually works with a lot of different platforms. And if you want to jump the slide head here a little bit. What we have, you know, he talked about Autopilot, and what we've actually done is we put a community edition together, which allows everybody who wants to have an opportunity to try a lot of these things out. You can do it for free. You know, we have, as you can see on here, you get about 20 intelligence gates, which is, you know, on about 1 month of audit and traceability, and it could help anybody who wants to try something to start automating these processes like he showed. And it works, you know, out of the box with both the tools that he just highlighted. So, you know, we'll send information to everybody who attended today where they can get access to Autopilot Community Edition. And if you guys have questions about that, feel free to ask them. We'll get to the Q&A section here in a second. What I want to do real quick is actually do another quick little poll that we'd like to run at the end. So I'm going to launch this poll really quick for everyone. So feel free to kind of go through that, and we'll run this for a few more seconds. Thank you everybody for who's answering on this. All right. Well, thank you everybody for responding to the poll. And we will be in contact with all of you who are interested in a demo and more information about the tool. But with that, I think we should open the floor for some Q&A. So we have a few questions that came in during our talks today. I figured I'll start with a few of them right now. Vasantha, if you're ready.
Sure.
All right, let me see here. So first one, it's around Autopilot, and you talked about how it can be used for Canary Analysis for deployments. And there are other open source tools that can automate the Canary Analysis. What makes Autopilot different than those tools?
Right. So, of course, probably you're referring to Kayenta. This is one of the open source tool which is already available for Canary Analysis, right? So we are similar in some respects, of course, yeah. So that no, but as you have seen earlier, Canary Analysis is only one of the features we support, along with a host of other features in the delivery intelligence module. So we have continuous verification, which can be used in different stages of software lifecycle, not just for deployments. Okay. Autopilot, in addition to verification, also supports few other features like policy compliance, automated approval, audit trail, which are not available, say, in other tools such as Kayenta. And also we support analysis of logs, as you have seen earlier, in addition to analysis of metrics. Simultaneous analysis of logs and metrics can also provide useful insights on what is going on in the anomaly, in case of anomalies, right? So, and also we keep adding a lot more and more data sources for Canary Analysis. For example, only last week, we had our latest software release where we added integration with Tanzu observability. So this comes from VMware. So there's a good chance that we may already be supporting your favorite monitoring provider already, right? So that's in brief how we compare with other tools.
Awesome. So another one that we had here is, you mentioned policy and compliance earlier in the presentation. What kind of policies do people use with our solutions? Is there a limitation? Do they have to be a specific type? Like what kind of policies and compliances can be done with Autopilot?
Right. So broadly, there are two categories of policies. Of course, our policy engine, what we have, and the policies are kind of CI/CD specific, right? So the two categories, among the two categories, the first one is what we call as the runtime policies, right? So these can be inserted in your pipeline and is specific to that pipeline. Example could be that you want to restrict a pipeline execution within a certain time window, or say, for example, outside the working hours. Another example could be a policy which checks security scan results from a SaaS tool and allows promotion of software update to production if there are no critical issues, right? So this is another uh, policy which is specific to a pipeline, right? A second category of policies is more generic and applicable to all the pipelines in your CD platform. So typically these will involve some kind of RBAC, right? So role-based access control. For example, one of our customers use a policy which validates if there is at least one user group which has write access to the pipeline before saving it. Another customer uses a policy which blocks a developer from modifying a critical stage in the pipeline. He still wants the user to have write and execution access to the pipelines, but wants to protect only some stages, some kind of partial RBAC, which is only possible with policies, right? So these are broadly some examples of the kind of policy that are used by our customers.
Awesome. Well, thank you for giving those examples. Another question that we had is around integrations. You said that, we integrate with a lot of different CI/CD tools. How do we use these integrations in the pipeline if we're using Autopilot?
Right. So there are at least three different ways, right? So one is what we refer as the CI integrations, right? So where we may need to use some of these stages such as Jenkins build stage in our CD pipeline. We will need a source code repository such as GitHub or Bitbucket for GitOps to keep our pipelines, right? So these I'll call them as CI integrations. That's one category, right? Another category of integrations are with monitoring providers, both logs and metrics providers, Splunk, say Prometheus, Elasticsearch, Datadog, New Relic, right? So, or Graphite, right? So these are for verification use cases, such as Canary Analysis, okay? So this is the second category. Then we have a third group of integrations, like say integration with incident management systems, such as say Jira or ServiceNow for automated approvals. In a CD pipeline, we can pull the list of issues which are getting fixed in a current software update and check if all are done or in a done state before promoting it into production. We also provide integration with Slack, Microsoft Teams, etc., so that you can get notifications regarding the status of your pipeline executions, right? So this is the third category of integrations, okay? So broadly, CI integrations, monitoring providers, and integrations with incident management and notifications. Yeah.
Awesome. Well, thank you for all of that. We're actually out of questions if nobody has any more questions. Thank you everybody for attending. Thank you for Santhan for a great presentation. And with that, everybody, have a great day, and we will see you on our next webinar. Look for more information from us on the presentation deck that's going to be coming out to everybody, along with a link to the recording. We'll also be sending out information about our next upcoming webinars as well. So thank you, everybody. Have a great day, and we'll see you soon.